Okay, we've got to solve a trig equation. The first thing we see is there's a squaredy trig term in here. We've got sine squared x. Okay, and your instincts say, oh, I've got sine squared x. I could turn it, if I wanted to, into 1 minus cos squared x. In this particular case, we can see that the other term is actually already a sine x, so there's no need to follow your instinct to maybe deal with the squaredy trig, but it's good if you notice it. Okay, in this case, we just need to recognize this is really a quadratic equation. Okay, we can keep just writing out sine of x all the time, but it's quite good. It makes it look simpler if we just use the letter s to mean sine x. If you're going to do this, you should say what s is meaning. It's like when we do any hidden quadratic. If we name the thing that it's a quadratic in, this now it means sine squared of x means sine of x in brackets squared. So this is 2s squared minus s equals 1. In fact, I'm going to take away that 1 from both sides. So this equation becomes this very obvious quadratic here. So all we have to do is solve the quadratic. This one factorizes pretty nicely, I think, but there's no harm in using your calculator. And you get the solutions 1 and minus a half. Although it looks like we have solutions, of course, all we've done here is found out what s is, and s was sine x. So we now need to solve sine x equals 1 and sine x equals minus a half. Now, the normal method is to do first solution, second solution, look for 2 pi repeats. For sine x equals 1, though, that's such a simple one, you're best off just thinking about the graph of sine x. So we're only going up to from 0 to 2 pi, so I can draw the whole graph, and I can see the only value in the range 0 to 2 pi where I get an answer of 1 is this first one here, which is pi by 2. That's one of the values you should know. So for this one, we just get x equals pi by 2 without touching our calculator. Okay, for sine of x is minus a half, then we are going to get a first x and a second x, and the first x is going to be arcsine, I should say, arcsine of minus a half. Okay, it's one of those exact values that maybe you know, but with the minus on it, you probably will end up using your calculator. But arcsine of minus a half, your calculator will give you as minus pi by 6. Okay, and for the second x, we know the method for second x. We need to make the method clear. We need to do pi minus the first x, which was already minus pi by 6. So this is 6 pi by 6 plus 1 pi by 6. So this is going to be 7 pi by 6. Your calculator can do a lot of this for you, but you should be able to handle the fractions. Now, these are our first solution and second solution. Now we need to consider, do we need any 2 pi repeats? Well, this first solution is actually not itself in the given set of values, but if we add 2 pi to it, we do get 1 in the given set of values. This one here is already in the set of values. Adding or subtracting 2 pi would take it outside. So the two solutions we're going to get, our final answers for x, this 7 pi by 6 that was already within the right interval, and the other one, pi by 6, minus pi by 6 plus 2 pi actually becomes, what's it become? It becomes 11 pi by 6. And those are our two answers for x, so double underline them. So we've recognized this as being a quadratic. If we want to change the letter to s, then say what s equals in terms of sine x, show your answers to the quadratic clearly, and then clearly solve the two possible solutions, find the x's that apply. Okay, and bring all of your answers to the end. So that's what I haven't done. Okay, I've given my two answers to this second equation together here, but I had this other solution, pi by 2. So I need to put that in at the end. So now I have a complete set of answers. So it's always a good idea just to check you've done everything you should have done at the end.